Greetings, Mr. Sutton, bringing you the Pre-Cal Honors 9-3 Extra Practice Number 2 solutions on algebraic limits of polynomial and rational functions. On this one, I'm trying to find the limit as x approaches 0 of this linear function. Since this is a polynomial, which is continuous, that means that the limit and the function value are always going to be the same thing. So we just have to plug in 0 here, which gives us a limit of 5. For this one, to find the limit as x approaches -1 of this line, since it's linear and a polynomial, that means function values and limits are going to be the same thing. So I just have to plug -1 in to find the limit. So 2 times -1 minus 5, that's going to be -7. To find the limit as x approaches 2 for this polynomial, since it's a polynomial which is continuous, that means that limit values and function values are always the same on these. So just plug 2 in for all the x's and see what it comes out to. So we've got 8 minus 12, so far that's -4, plus 6 gives us 2 for our final limit. To find the limit as x approaches -1 on this rational function, since there's no way this thing can possibly come out to 0 over 0, I'm just going to go ahead and plug -1 in right away. So 3 over -1 squared plus 3, that's really 3 over 4, which I can't really reduce anymore. To find the limit on this one as x approaches 1, I could try factoring this, although it's not really factorable, but I notice right away if I plug in 1, I'm not going to get 0 in the numerator or the denominator. So I'm just going to plug 1 in straight off the bat. So that gives me a 4 in the numerator, and let's see, this is going to be 5 in the denominator. We still have that negative out there, so that ends up being -4/5. On this problem, I notice right away that if I plug in 1 trying to find this limit, I'm going to end up with 0 in the numerator, probably also the denominator. Let me factor this and just make sure there's no common factors I can cancel. So things that multiply to -3 and add up to 2, that would be, let's see here, x plus 3 and x minus 1. So it turns out those x minus 1s can cancel, and now I'm just left with 1 over x plus 3, limit as x approaches 1 of that. Just plugging in 1 now, we end up with 1 over 4. For this problem, I can see right away that when I try plugging in -3 to find this limit, I'm going to end up with 0 in the denominator. Let me factor the numerator and see if there's anything I can cancel. So numerator, let's see, things that multiply to 3 and add up to 4, we can actually split that up into x plus 1 and x plus 3, which is going to be helpful for canceling out that denominator. So now this is just limit as x approaches -3 of negative parentheses x plus 1. Now I can plug -3 into that since I'm not going to get 0 over 0. So -3 plus 1 is going to give me -2 inside that parentheses, but there's a negative outside as well, so that reverses to +2 when all is said and done. On this one, trying to find the limit as x approaches -3, you'll see very quickly if you just mentally try plugging -3 in for x that we end up with 0 over 0, which is no good. That means we can factor. The numerator can be split up into x plus 3 and x minus 3. And now those x plus 3s can be canceled out. So that was the 0 over 0 that we were getting, or at least the cause of that. Now that we've canceled that out and we just have x minus 3, we can actually go ahead and plug in -3 for real. So that's -3 minus 3, giving us a limit of -6. For this problem, with limit as x approaches 3, I can see right away that if I plug 3 in the numerator, I'm not going to get 0. So I'm just going to plug 3 in for all the x values and see what happens. We end up with let's see here, this is 3 squared over 3 times 3 minus 9. So this is 9 in the numerator, 0 in the denominator. This is actually undefined, which means that our limit does not exist. We've got a vertical asymptote going on. For this problem, I can see right away that if I plug in -1 down here, I'm going to end up with 0 in the denominator. But there's nothing I can really do in terms of factoring and canceling, so I'm just going to go ahead and do that. So we end up then with -1 over 0, which means we're dealing with a vertical asymptote, which means that the limit does not exist. It's some kind of infinity, and we're not going to worry about which one. On this problem, I can see right away that if I try plugging -6 in the numerator, I get 0, which by itself isn't bad, but if it happens in the denominator, then I'm going to have to go back and factor this. So let me just go ahead and factor this right away. It looks pretty easy to factor. Two things that multiply to 30 and add up to 11. That would be x plus 5 and x plus 6. And it looks like those x plus 6's are going to cancel. So that is actually canceling out a 0 over 0 that I would have gotten if I plugged in negative 6. Now I'm just left with negative 1 over x plus 5. And now if I plug in negative 6, I'll at least get something other than 0 over 0. So plugging that in, we end up with negative 1 in the denominator. That cancels with this negative here. So overall, this is just a limit of positive 1. For this problem, I can see that if I plug in 4, I end up with 0 in the denominator. Let me try factoring the numerator and just make sure I can't cancel anything out before that happens. So things that multiply to 4 and add up to negative 5, well, how about x minus 1 and x minus 4? Oh, how about that? The x minus 4's are canceling out. So when all is said and done, I'm really just taking the limit as x approaches 4 of negative x minus 1 in parentheses there. So that's just going to be, if I plug in 4, this is going to be negative 3 when all is said and done.